Saxon Algebra 1/2, lesson 108. Our topic is fractional percents. And this is, let's just jump right in so you can see what I'm talking about. It's not that big of a deal, but it can look confusing at first. Write each percent as a decimal number. 4.2%. Okay, what do we do? This 0.2, we know how to write 4%, right? If it was just 4%, to write that as a decimal, we'd write 0.04, right? But to write 4.2%, this is what we do. We write the 4%, and then this 2/10 represents the next decimal place down. Does that make sense? I don't want to talk a bunch of theory to you. I just want to show you it's super easy to calculate that. What about 0.05%? Whoa, okay. We just move another way to look at this is to just say we move the decimal places 2 places to the left, right? So this one would be 0.0005. That's probably the fastest and easiest way to explain this to you. In order to change this percent into a decimal, we move the decimal places back. That's how I think of it, back to the, which way is that? That's left, okay? 2 decimal places. To the left. See? 4.5%. Well, again, we can write this. Let's take the fraction out. Let's do it as 4.5, right? And then bump it twice, 1, 2. So it would be 0.045. And then D is 0.03%. All right. In order to change this into a percent, we have to write this as a decimal. I can change this denominator by multiplying top and bottom by 5. I get 15/100. And then I can write this as 0.15%. We're still in percent mode, right? We haven't switched it out. And so then 2 more will be 0.0015. That's a little confusing, isn't it? This last one was a little bit confusing because we had to take 3/20 of a percent, switch that into a decimal. We found out that it was 0.5%, right? This was all still keeping it as a decimal. We just adjusted so that our fraction was over 100 so we could switch it into decimal format. And then finally, as our last step, we did that 2 decimal places to the left to get our final answer. So these are our 4 answers. As you're getting the hang of this, you can look back to this work and see, okay, that kind of gives you a guideline, right, of how to adjust each type of number. This one's the trickiest. Okay, let's go on to the only other example for this lesson, 108.2, 4.5% of the students did not brush their teeth every day. Oh man. If there were 1,200 students in all, how many did not brush their teeth every day? Okay, so here we have students. This is a frickin' formula problem. right? Special groups. And in this case, it's a percentage problem, right? So there are our formulas. We're gonna want this one because we have percent. So we have all these students, and I'm not gonna worry about drawing that line proportionally. I'm gonna say did brush and did not brush. Okay, we're talking about percents, so the original group is 100%. And then we find out that 4 1/2% did not brush their teeth every day. Okay, so this is 4 1/2%. That means we can figure this out. This would be what, 95 1/2% did brush their teeth every day. Whew, that's a relief. If there were 1,200 students in all, how many did not brush their teeth every day? So that's what we want to find out. Okay, so we use this formula, our percent times the total group equals the special group. Okay. And so now we can change this to 4.5 over 100, right? And there's a couple ways we could do it now. We could reduce and multiply. I'm going to show you a couple different ways. So this is the first way. We're just going to reduce and multiply here. So, oh, this is wrong. This should be times equals x. So I'm going to reduce like this, and then I'm going to go 12 times 4.5, 10, and 48, 0, 4, carry the 1, 54. Decimal place, there's 1 behind it. So there's 1 there. So we get x equals 54 students. Okay, so this was our first strategy, and what we did is we just changed this into a decimal number and went from there directly. Another way we could do it, going back to where we were, a lot of times when we have decimals, what we'll do is we'll just multiply this number by 10 over 10 in our heads. I can do it like this. And what that will do is that will move this decimal place out, but we'll also have to move the decimal place there. So now I'll have 45 over 100 plus 1 more 0 to make it 1,000, right? See, I'm bumping in the decimal place once, times that equals x. And then here, let's see, this would be, I can say that 200 goes into both of these numbers. 200 goes into this 5 times. 200 goes into that 6 times. I can cancel here and get 9. 9 times 6 equals 54 again. Okay, so there's another way that I could do it. Another way, a third way I can think of that we could do it is way back here. We're copying the original problem again. What I could do is I could recognize, oh, 4.5 over 100, I can simplify that by moving this 1, 2 times. So I would have 0.045 times 1,200. Okay, so let's just do the math on this. 0, 0, 0, 6, and then we put an extra 0 there, and then we go 0, 0, 48, and this becomes 0, 0, 0, and then 1, 2, 3 decimal places, and there's our 54 again. So here's what I want you to take away from this little exhibition of options that you have. In a problem like this, once you get your diagram and you set up your original equation like this, right, there's the percent over 100 times the total group, whatever your brain sees as the best way to simplify this, trust your brain. All right, there's 3 options I can think of right there. So you may even be able to think of more. Do whatever you trust. Just remember that if you want to look at this and change that into a decimal, first you go to 4.5, and then dividing by 100, you'd move it twice. So this would equal 0.045. Okay, but there's lots of ways to do it. Do what feels right in your brain, Caleb. It'll be fine. Okay, thanks. See you next time.